the point is, today's Thursday, so let's have some fun on your favorite day of the week and get started with some more discrete math. And today we're going to do some more of this divisibility stuff we've been talking about, which is fun. And, you know, divisibility is kind of cool because it's an easy enough definition that, like, right away we can get into it and actually prove some interesting things. And today we're going to end with what's called the fundamental theorem of arithmetic. Yes, that's how important it is. There's the fundamental theorem of algebra. There's three fundamental theorems that you guys have probably gone over in your life: the fundamental theorem of arithmetic, algebra, and calculus. And I think we're only going to do the arithmetic one in this class. But anyway, so it's going to be fundamental. It's going to be awesome. So let's just start off with a really nice divisibility fact that's super easy to prove. And we're just going to prove it real quick so we can use it. So we are in our divisibility proof. So we're kind of somewhere in the 4.3, 4.4 range. It all blends. And yeah, so here's the claim. I mean, now we're in the part of the class where it's kind of awesome. It's just going to go like claim, proof, claim, proof, claim, proof, which is kind of the fun part. Let's just get to thinking here. So the claim is that A divides B, or I'll say whenever A divides B, A will divide B times C for any integers A, B, and C. It's just a really casual way of saying it. I might as well have added a bruh at the end, right? This is just like the English, like, but the point is, what's this saying formally? Like, let's just kind of get rid of any interpretation differences. What's this actually saying? First of all, is it a universal statement or an existential statement?
Universal, right? For all
Universal,
A, B,
right?
C, and the integers.
Exactly. And so what I'll say is, be careful here. It's kind of tempting to say like for all A, B, and C, and Z.
Z cross Z cross Z.
Yeah, which totally makes sense. However, what we really need to do is we either need to talk about A, B, and C separately, or talk about A, B, and C as a group. So what I mean by that is the actual formal way to write this would be for all A and Z, for all B and Z, and for all C and Z. We get that whenever A divides B, A divides BC. Otherwise known as if A divides B, then A will divide BC. So what I'm saying is A divides B implies A divides BC. All right. Or what you could do if you really want to, if you really want to get fancy, is you could consider A, B, and C a group, and you could say for all ordered triplets, A, B, and C in the set Z cross Z cross Z, AB implies A divides BC. It depends what you want to do. I think the top one's more common. It's not wrong, maybe easier, but the bottom one's also not wrong. So do as you wish. Well, the point is, yeah. So this is the formal claim, and the first
question.
Yeah.
Is there a difference between Z cross Z cross Z and Z3?
Nope, they're the same thing. Actually, this it's this equals Z3 is what I'm saying, because it actually follows the exact same notation as like algebra, where like 2 times 2 times 2 equals 2 cubed. Same exact idea. And there's reasons why we call this multiplication. There's also a form of kind of set addition, but that's all abstract algebra nonsense. Actually, it's sense. It makes sense. So just that's just a bunch of abstract algebra sense. Well, that's for like 5 classes from now, 6 classes, whatever it is. So we'll leave that for them. You know, we can give them something. You know what I mean? We can't have all the fun in this class. So the point is, yeah. So this is the claim. And here's the question. Is it true? Let's do our little aside here and see. Like, what do you guys think? Do you think this will always be true? Can we ever break it? Well, first thing maybe is do an example to see does this make any sense at all. So let's see, like for example, 3 divides 6. And if we pick any integer c, like 2, 3 will divide 6 times 2, which equals 12, right? 3 does divide 6 because 6 equals 3 times 2. And 3 does divide 12 because 12 equals 3 times 4, right? So we have 3 times an integer multiple is the point. So it worked for 3.
H probably can't be 0, right? Like you can't have 0 divide something.
Well, I kind of see what you're saying, but actually the statement kind of works itself out, right? So if 0 divides, like 0 divides, so remember, we'll say A divides B. By definition, that means that there exists a K and Z such that B equals AK. So if we're saying 0 divides B, what's that saying? That there exists a K and Z such that B equals 0 times K. But 0 times K for any integer K, we know it's going to be 0. So the point is, you're right. 0 divides B only if B equals 0. You're totally right. However, right, we're just saying that if A divides B, then A will divide B times C. So if A was 0, so in the case where A is 0, if 0 divides B, well, that means B is 0. And so then 0 will divide B times C no matter what C is, because that's going to be 0 again. You see what I'm saying?
Sort of, and otherwise it would be like vacuously true, right? If B is, right, if 0 doesn't divide B.
Exactly. All we have to prove is that in the case where A divides B, it will divide B times C. And so let's actually kind of get a little down and dirty with the math here. So A divides B, what's that mean? That means there exists a K such that B equals AK, right? But now, let's look at B times C. B times C, based on this, well, B is going to be AK. It's going to be AK times C, otherwise known as AKC, right? So from this, we can see we didn't really have to consider if like 0 in all these cases, because the point is, this actually kind of this kind of actually brings up the beauty of direct proofs again. The whole idea of a direct proof is just like you're not looking at specific examples, but instead you're just looking at just general properties, right? And A divides B, the property that A divides B, what that means is that leads to the property that there exists a K, such that B equals AK. And having that property means you multiply it by C. Well, we can do this whole thing with the associativeness of all that, and you get A times KC. So having A divides B will lead to that, and will lead to this in general. It doesn't matter what A, B, and C are, just the property of A dividing B will lead to this being true, will lead to the property of this being true. And so we don't even have to consider we don't have to consider anything. We just see, oh, it's gotta be true. Does that make sense? Hope the answer there is yes. The point is that we just follow the math, follow the algebra basically here. We can see like every step along the way we did a valid operation, and so we can't possibly be false. So yeah, but the 0 thing, if we want to get into it a little more, just to make us just to kind of give her that little nagging feeling of like, but what about that? If 0 divides B, that means there exists a K such that b equals 0 times k. 0 times k always equals 0. So 0 divides b means that b must equal 0. Then for any c, b times c is going to equal 0 times c, which is 0. And 0 does divide 0 since, for example, 0 equals 1 times 0. It's an integer multiple. This is weird. This is weird because this is where divides and division divide. This is where they separate, right? Because we're not saying that 0 divided by 0 exists. It doesn't. This is undefined. And the reason it's undefined is because you can actually put a 2 here and a 3 here and a 4 here. You can put anything. You can put any integer multiple here and it would work. But the point is 0 divided by 0 is undefined. So the division of 0 with 0 is undefined. But by our definition of divides, 0 does divide 0, since you can find an integer multiple to multiply 0 by to get 0. It's kind of complicated. It's not really complicated, it's just like messy because we have 0 running around everywhere and stuff like that. But I hope this sinks in and makes some sense. Any questions? What if I smile louder? Okay.